Okay, so welcome to lesson 2. And in this lesson, we're going to look at limits and we're going to evaluate them algebraically. So our objective today is to use various methods to find limits. And once again, most of this you should have seen in your pre-calc class. So there are 4 strategies to evaluate a limit. The first and most popular, and the one we do first all the time, is direct substitution. We always want to start with direct substitution. And direct substitution is simply just evaluating the limit. Now, direct substitution, we always start there because it's quick and dirty, but sometimes it doesn't work. It will not work if you get 0 over 0 or infinity over infinity. So if you try direct substitution and you either get 0 over 0 or infinity over infinity, you have to try one of the other methods. And the first method is just algebraic manipulation. Algebraic manipulation. And that could be simply multiplying or simplifying in some way. The third thing we want to try is factoring. And then, oh, there's a G there. And then we want to try rationalization. Now, up until this point, math teachers have drilled in your head to rationalize the denominator. But here, we can sometimes rationalize the denominator, but sometimes we may rationalize the numerator. It just depends. We're just trying to get rid of the radical wherever it appears. All right, let's do some examples. Now, as I said, we always start with direct substitution. If we get anything other than 0 over 0 or infinity over infinity, direct substitution is the quick and dirty way of evaluating the limit. So if I start with direct substitution, meaning I'm just, every place I see 3, every place I see x, I'm going to replace it with 3. So I get the square root of 3 plus 1 over 3 minus 4, which gives me the square root of 4 over negative 1, which is negative 2. So since I didn't get 0 over 0, infinity over infinity, I'm good. So that is just negative 2. Easy peasy. Okay? So the next one, I start with direct substitution. I am substituting in negative 3, so I get negative 1 cubed plus 1 over negative 1 plus 1. Now I've got a little bit of a problem. Negative 1 cubed is negative 1, so I get negative 1 plus 1, and negative 1 plus 1, which is 0 over 0. Bummer. So I have to do something different. Well, I can't just sort of multiply this out, but I can factor. Remember, that was one of our ways. So recall from, I don't quite remember when you guys learned this, maybe Math 2, how to factor the difference of 2 cubes. We're going to use SOAP. So to factor the difference of 2 cubes is x plus 1. And then it is same, opposite, always positive, over x plus 1. Now, we see that the x plus 1s will cancel each other out. And so now we're left with the limit as x approaches negative 1 of x squared minus x plus 1. At this point, we're going to come in and try to do a direct substitution again. So this will give me negative 1 squared minus negative 1 plus 1. And if I think this would be 1 plus 1 plus 1. So my answer is 3. Okay? So we had to use another method, in this case factoring, but then after we factored, we had to go back and do a direct substitution. Now you may remember from pre-calc that this is going to produce what we call a whole. Okay? Now, once again, we always want to start with what? Direct substitution. So I'm going to substitute in 0 for x, and I get the square root of 2 minus radical 2 over 0, which gives me 0 over 0. Indeterminate, meaning I have to do something different. because I have radicals here, I'm going to rationalize it. When I rationalize it, what I'm doing is multiplying by the conjugate. So recall, to find the conjugate, the numbers remain the same. The only thing that changes is this becomes positive. And I'm going to multiply both the numerator and the denominator. Okay? So recall that from Algebra 2. I'm sorry, you guys don't take Algebra 2. I think Math 2, maybe Math 3. Okay, so the neat thing about multiplying by the conjugate is that it's going to get rid of the radical in the numerator. Just to save space, I'm going to erase my direct substitution work. And now we're going to multiply this. Now, I'm going to, in the first time I do this, I'm going to multiply it out. In the future, I'm not going to multiply this out. So radical 2x, radical 2 plus x times radical 2 plus x gives us parenthesis 2 plus x. Now, doing FOIL, we see that we get radical 2 times 2 plus x. And then, I'm sorry, that would be positive. And then when we multiply the negative radical 2, we get minus radical 2, 2 plus x. And then radical 2 times radical 2, and it's going to be a negative, so that's going to be square root of 4. Okay, what I want you to see, and this will happen each time, these two zero each other out, because we have a positive and a negative, and they're going to zero each other out, so we don't have to worry about this middle term, and in the future we just look at the first term we multiply and the last term we multiply. That's all we need to look at. So simplifying this, I get 2 plus x minus 2, because the square root of 4 is 2, all over x times square root of 2 plus x plus radical 2. Simplifying the numerator, 2 minus 2, that zeroes out, and I'm left with x over x square root of 2 plus x plus 2, plus radical 2. Now, notice, what can I do with these x's? They cancel each other out. And up until this point, I've been a bad math teacher because I really should write this as the limit, because I haven't taken the limit yet, as x approaches 0. This simplifies, so I'm left with 1 over the square root of 2 plus x plus radical 2. Now I'm going to do a direct substitution, and for x, we're going to replace it with 0. So I get 1 over radical 2 plus radical 2, which is 1 over 2 rad 2. And that is our answer with the direct substitution. A lot of work, right? The radical ones are a little bit more work. There's some in your practice problems, so I would just encourage you to do more of those. Okay, we're going over to the next one. Now, don't let these delta x's scare you. Also realize that x and delta x are two different variables, so I can't combine these together. They're two different variables. So this delta x, if it's bothering you, you can change it to y if you like. And we're looking at the limit as delta x approaches 0. So I'm going to use algebra here and just multiply this out. I'm going to FOIL this out. Now, also, at this point in your math career, you should be able to do this in your head. So what we have is x plus delta x squared, or x plus delta x times x plus delta x. I am going to, once again, I'm going to multiply this out one time, and then after that you should be able to do it in your head. So this is going to give me x squared. This is going to give me x delta x. That's going to give me x delta x plus delta x squared. Notice that these two we can combine, so we end up with x squared plus 2 delta x plus delta x squared minus x squared over delta x. Now, I haven't done anything, and I did you're probably right. I didn't do my direct substitution, but if you go back and do direct substitution, you'll see you end up with 0 over 0. Okay, I kind of skipped the gun on that, but you need to make sure you do that each time. So simplifying this, you notice that my x squares are going to 0 out, and I'm left with 2 delta x plus delta x squared over delta x. Using my factoring technique, I have a delta x in each of these. I'm going to factor out delta x, and I'm left with 2 plus delta x, all over delta x. And again, being a bad math teacher, I should be writing the limit as delta x approaches 0. Notice here that the delta x's will cancel each other out, and so I have the limit as delta x approaches 0 of 2 plus delta x. And the limit as x approaches 0, well, this goes to 0, and I'm left with just 2. Beautiful, isn't it? I think it's quite eloquent. Okay? Again, we have another problem, and I'm going to do a direct substitution. I'm going to be a good math teacher and do a direct substitution first. As I substitute in 0, I get 1/3 minus 1/3 over 0, which is 0 over 0, which is indeterminate, and I have to use another method. What I'm going to do here is I'm going to use something that I call Boldenism. It's actually a legitimate math shortcut, but I'm just going to kind of show it to you here. It's A over B plus or minus C over D. And anytime you get this, you can multiply A times D. And then whatever sign this is, it will be whatever sign that is. And then we multiply B times C. We get BC all over B times D. Our students call that Boldenism, but it's a legitimate math expression. And you can quickly find, all I'm doing is finding the least common denominator, but it can be done really quickly this way. Your Math 2, Math 3 teachers probably won't like it, but it's a quick and dirty way of simplifying when you have an expression like this, when you have a complex fraction. So using that, I'm going to do 1 times 3, which is 3. Since this is subtraction, it's going to be subtraction, and then 1 times 3 plus x, which would just be 3 plus x. But you have to be careful here and make sure you put that in parentheses. Then multiply the denominators together, and I get 3 times 3 plus x all over x. My advice to you is not to try to distribute this, just to leave it this way. Okay? And once again, I should be writing the limit as x approaches 0. All right, let's simplify this numerator. 3 minus 3 is 0, and I have this negative x here because that negative would distribute over 3 times 3 plus x. But when I divide, I can multiply by the reciprocal. Do you notice if anything is going to cancel now? So we see that the x's cancel, and I have negative 1 over 3 times 3 plus x. And I am taking the limit as x approaches 0, which is going to give me well, it's the limit as x approaches 0, we make that 0, and that just becomes negative 1/9. Yay? Okay. Let's do another one. We have x minus 3 and x squared minus 4x plus 3. Let's start by doing a direct substitution. 3 minus 3 is 0. And I get 9 minus 12 plus 3. So that's negative 3 plus 3, 0 over 0. So you're going to like this one. This is not so bad. All I have to do is factor. What can I multiply to get 3 and add to get negative 4? Then what happens to my x minus 3's? So I have the limit as x approaches 3 of 1 over x minus 1 which is 1 over 3 minus 1, which is 1/2. And that is my answer. Okay, so I want you to take a moment and practice this. You want to pause this, and you want to complete the Find Limits algebraically worksheet. And when you are done with that, you can come back to the video, and we're going to just kind of finish up. We're going to do the properties of limits. That's a very short section. All right, the properties of limits. And it's basically this. The sum of the limits is the limits of the sum, which means the limit as x approaches c of f of x plus the limit as x approaches c of g of x can be written as the limit as x approaches c of f of x plus g of x. So the sum of the limit is the limit of the sum. The same thing for the product rule. We can write this as the limit as x approaches c of f of x times the limit as x approaches c of g of x. That can be written as the limit as x approaches c of f of x times g of x. So the product of the limit is the limit of the product. Scalar multiplication, the limit as x approaches c of, let's give it some constant k of f of x is equal to k times the limit as x approaches c of f of x. Quotient rule, the limit as x approaches c of f of x divided by the limit as x approaches c of g of x is equal to, you got it, the limit as x approaches c of f of x over g of x, but you have to remember in this case g of x cannot equal to 0. Otherwise it would be undefined. And the root says that the limit as x approaches c of the square root of f of x is equal to the square root, if I can write that, of the limit as x approaches c of f of x. And those are your basic properties. And you might say, well, this is very simple. This is not always the case. When we get to derivatives, we see that those rules do not apply. But in this case, they're very simple. So let's just do a quick example. We're given that the limit as x approaches c of f of x is 3/2, and the limit as x approaches c of g of x is 1/2. So the first thing is, what is the limit as x approaches c of 4 times f of x? Well, from what we just learned, we can write this as 4 times the limit as x approaches c of f of x. And we know that the limit as x approaches c is 3/2, so therefore this is 6. I hope my math is right. Okay, again, we can write this as the limit as x approaches c of f of x times the limit as x approaches c of g of x, which would be 3/2 times 1/2, which is 3/4. The sum of the limits, this can be written as the limit as x approaches c of f of x plus the limit as x approaches c of g of x, which in this case would be 3/2 plus 1/2, which is 4/2, 2. And yes, you understand it perfectly at this point. The limit as x approaches c of f of x divided by the limit as x approaches c of g of x, which is going to be 3/2 divided by 1/2, which is 3/2 times 2 over 1, which is 3. Yay! So simple. Okay. Now, we can use those rules to simplify trig functions. Now, in some of your books next year, they will call this the squeeze function. I generally don't teach the squeeze function. It's basically this. Remember from what we did earlier in the last video, we found that 1 minus cosine x over x is equal to 0. The limit as x approaches 0. The limit as x approaches 0 of sine x over x is 1. So you need to remember this for now. But later you're going to learn L'Hopital's rule, so you won't even need it to remember it then anymore. But for now, just remember this. And we can use these properties to simplify expressions. Okay? So, for instance, we're going to use the properties that we learned before plus these two, let's call them identities, or truths, I don't know what to call these, to simplify this. So what do we know? Tan x over x. If I can write this in terms of sine and cosine and get it to look like this, I might be able to do something. So tan, I know tan is sine x over cosine x. So this is sine x over cosine x over x. Now, I hope that it's okay with you if I were to write this as the limit as x approaches 0 of sine x times x cosine x. If you don't understand how I wrote that, what I did was I simply just multiplied by the reciprocal. That's all I did. Okay? So now, look at this. I have sine x over x. And I know the limit as x approaches 0 of sine x over x is 1. So I can write this as the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over cosine x. I know that this limit is 1, and if I do a direct substitution here, 1 over cosine, when cosine is 0, is also 1. So I get 1 times 1, and this limit is 1. Isn't that cool? Trust me, it's cool. Okay? Now, for this one, it looks similar to sine x over x, but I got this 4 here. So what I need you to know is that it doesn't matter what this x is as long as they're the same. So this could be sine over 2x, 2x. And that limit as x approaches 0 would equal to 1. Or this could be 8x. And you still get 1. So it doesn't matter what that is. We could actually say that it is, going back to pre-calc, we could say the limit as u approaches 0 is sine u over u. Okay? Where u could be 2x, 4x, 8x, it could be anything. So if I want this to be in this form, I need a 4 here. Well, I can't just willy-nilly put a 4 there, can I? But I can if I multiply both the top and the bottom by 4x. Okay? So that gives me 4 times the limit as x approaches 0 of sine 4x over 4x. And we know from this property that this is 1, so my answer is 4. It's a nifty little tool, okay? This one is similar to the one that we did before, but now we have this squared here. So tan squared is sine squared x over cosine squared x. And once again, I'm just going to bring this x here, and we're taking the limit as x approaches 0. So can I write this then as the limit as x approaches 0 of sine x over x times sine x over cosine squared x. Okay? And the limit as x approaches 0 of sine x over x is 1. And the limit as x approaches 0 of sine x over cosine squared x, doing a direct substitution, I get 0 over 1, but that's still 0. Okay? So for this one, I have sine x over 1 minus cosine x times 1 minus cosine x times 2x squared. Well, let's do some manipulation to this, okay? I can write this as 1/2, because I can take this 2 out, right? 1/2 the limit as x approaches 0 of sine x over x times 1 minus cosine x over x. There's a 1 there, you can't see it because of that. Okay? Now, this limit, we know this limit is 1, and this limit is 0. So I have 1 times 0, and I get 1/2 this limit, which is 0, so my answer is 0. Last one is similar to this one. In order for this to work, I need a 7 on the bottom. So I'm going to write this as 7 sine 7x. And what I do to the top, I have to do to the bottom. Using the commutative property of multiplication, I can rewrite this as 7 sine 7x times 4 times 7x. And again, this is 1. If I take the limit, my handwriting gets worse and worse as I get tired. Sorry about that. It's just that I think I have a little bit of arthritis going on here. The limit as x approaches 0 of 7 sine 7x times 4 times 7x. And what I'm going to do is just go ahead. We know that this limit is 1, so we're going to be left with 7/4. Okay? You are going to rock Calculus AB. Trust me. Okay? So that's all for now, and I want you to complete page 6 in your packet. Have a great afternoon, and I'll see you for the next lesson.